What's up guys, this is Santec IT Solutions, and today we're going to cover OSPF, or Open Shortest Path First. OSPF is a link state protocol, and it only advertises the state of its links. All the information gets stored in a database, and it will periodically update the database as things change in the topology. OSPF is very scalable, but it takes a fine tuning to get it to work properly. Otherwise you could really crash your network. OSPF is very comprehensive. It covers a lot of different things you can do in routing and network environments, but I'm ready to getting started here and jumping in the router. I just want to show you all the interfaces I set up, and I'm using loopback interfaces as our hosts. Basically, this would act as our default gateways out to different LAN networks on the other side of this Seattle router. So I'm going to start. The command is router OSPF, and then you need to put a process ID number. In this case, I'm just going to give it 10. The process ID number doesn't have to match the other routers. It can be unique. Doesn't really matter. I like to use different ones per router. But the router ID command must be unique, and it is required for OSPF to work on the router. So you put your router ID, in this case I'm using 10.10.10.10, and I'm going to start with our network. I'm already getting ahead of myself here, but you see something different about OSPF right away. You have to use something called a wildcard mask. So that 0.0.0.3 really equals 255 yada yada .252. That's would be the equivalent of its network mask. So I like to think of it as 255 minus 3 equals 252. So that's how you kind of figure out how that all works. And now the last part is the area command. So every network command consists of three parts: the network, the wildcard mask, and then the area command. So in this case, the 192.168 belongs to our area 0, which is the backbone. And another important thing to note is that all OSPF routers must connect to area 0. There is exceptions to this with something called a virtual link, but that's covered more in a CCNP test, and right now we're just going to stick with the basic stuff. So now I'm putting in all of my interface, my loopback interface networks. And I'm going to just put them in one by one manually to show you the process. And you see here I'm putting in network 10.10.1.2.3, and they're all in the same area, so they all belong to area 10. And what I'm doing is I'm basically just hitting the up arrow key, and that just brings back the most recent command I did, and I go back and I change the letter. It's probably, if you already have everything pre-configured in a notepad or something, you can cut and paste it in. That's what I'm going to do actually in the next two routers. I'm going to configure to speed things up a little bit. I just want you to get a good view of how the commands get entered and the syntax of the commands. It's always network address followed by wildcard mask by the area command. Now I'm going to just do show IP protocols, and now we're going to see our OSPF information, starting with the process ID at the top. And this is where you can also find your router ID, and this tells you if it's an area border router or your different area, and that we can cover in your OSPF studies. You'll find the different type of border router types. Or now I'm going to show you the IP route. So we have all these connected routes, and we don't have any other OSPF information or any other routing information because we haven't configured OSPF on any other routers. And you see there I entered the WR command, and that equals copy run start. It's a little shortcut. So see me using that, it just means I'm backing up my configuration. And on to the Chicago router. It'll just follow the same method we used before. This time I'm using process ID 20. I'm giving it a unique router ID. The router IDs must all be different. There's some other information about router IDs. If you don't put one in, it will default to the loopback address if one configured, or the lowest interface configured on the router. So I'm just going to start by first putting in our WAN links. That was the 192.168.10 and the .20. since this router is connected to both of those subnets, we have to put both of them in, and they're both in area 0, so that's good. And now I'm just going to show you the first of my LAN configuration, network configuration here. That's in area 20, and I'm going to cut and paste the rest in just to speed things up a little bit. So I just want to show you the protocol information again so you can see this comparison, and also to verify that all of my networks made it into the configuration. You see there, they're all there. And I'll show you the routing table now. So now that we have two different OSPF routers configured, we should see some OSPF information in there. So you can see there we have, I'm going to highlight it for you. We have our connected routes, and there's the OSPF information. It says OIA. So what if you look at our codes at the top there, IA stands for inter-area. That's because they're crossing an area boundary of area 10, and this one's in area 20 through, and it's going through area 0. Of course, it's our backbone. So now that one's done, so I'm gonna get started, finish up here on the final router here. Again, I like to keep the process IDs different, but they could all match. The process IDs doesn't matter. It's the router ID that must be unique. I always like to put them in to kind of match whatever area they're in. So let's say it was area 1, be router ID area 1.1.1 or whatever. But that has also more to play and more to do with the designated router and backup designated router function. And we'll cover that more in an advanced OSPF video. I want to cover some of the other things with OSPF, including one of the major things is designated router and backup designated router election process. Also, there's authentication for OSPF as well. There's timers, and those have to match, otherwise OSPF won't form neighborships. So the dead timer and the hello timers are important. And in this video I'll show you how to find those. But as you can see now, we have this big routing table here coming up. I'm going to show you. We have all these entries, and imagine if we had a dozen routers and all these different routes. Our routing table will get pretty big really quick. So I'm going to show you something after I'm done doing a few ping tests here. As you can see, we're getting connectivity and everything's going through fine. But we need to clean up that routing table. It's just too big. I'm going to show you the Seattle router, and just to show you that the routing tables match across the board. And that's what OSPF does. It updates the routing table on every router. And that's routing protocols essentially do in every route, in every network environment. They propagate routes and share routing information. So if we go into the router configuration mode again, I want to show you a neat command here called area, and then whatever your area range command. And I'm going to set it to 10.10.0.0. And you see here I'm using a .248.0. So that's going to summarize all my routes. It's going to give me .10.10.0 through .7. And that's why I set the loopbacks appropriate that way. I plan that ahead just to show you guys. So now I'm in Chicago router to show you the routing table is going to change. We're going to only have one entry for the now you see all these entries for the .30 network coming from New York. But if you see right here, that is one single route entry for the Seattle networks, and that cleans things up quite a bit, and it keeps the routing table from using up more memory. And I'm going to do the same command here on the Chicago router just to clean up the .20, the 10.20 network, using the same network mask. As you can see here, I made a little error though. I put 255.255.255.248. So I'm going to show you that that isn't going to work in a moment. Just to show you what happens when you make a mistake. You're going to see back in the New York router, I'm also going to configure it properly here for under the OSPF configuration mode, and I'm going to put the range as 10.30. But this time I'll use the appropriate .248.0. So I'm going to show you the routing table. We're going to see the summarized route for, we should see it for Seattle, but we won't see it. We're not going to see it for Chicago. Look, Chicago has all of our individual static route entries. Well, not static, but the individual unsummarized routes. So we're going to do some troubleshooting. We're going to say, oh, what's wrong here? How are we going to fix that? Well, obviously we got to go back to into the Chicago router and fix that configuration. So I'll show you how to edit a bad configuration in OSPF. When you're in a router, you basically look into your running configuration, as I'm doing now. I'm searching through to find the bad configuration. This is the first thing you want to do, is check your configurations. You can see here we identified the bad. Here's the culprit right here. I'm going to highlight it. That is the wrong mask. So I'm going to put in our OSPF command to get down to router configuration mode. I'm going to go into it and type no, and then basically put no in front of the same command that's bad, and I'll get rid of it. In this case, I'll also show you can copy and paste the same command in so you don't make any mistakes. I just have to clean that up a little bit and fix that, but in a moment I'll show you. Basically, you put the word no in front of the command that you want to remove. You just hit enter, and no news is good news. Now I'm going to put in the correct command. This is the right mask right here we need. And we should be good now. So, saving my configuration. I'm going to hop back into the Seattle router here and just see if our routing table updated. Alright, it looks good. We've got our summarized routes down there at the bottom for OSPF. As you can see, our connected routes are still all in there, and there's a different way to summarize those as well, but right now I'm just going to stick to OSPF. And I want to show you some ways to verify your OSPF configurations. So the first command I'm going to show you is show IP OSPF interface command, and you would choose the appropriate interface with OSPF on it. In this case, I'm going to just start with a serial interface. So if you see where I'm at here, this information is also very helpful in troubleshooting, and it tells you which area that interface belongs to, the process ID, the router ID, and the network type. Very important to know. Hello intervals and dead intervals can change depending on the network type you're using. So this one is a point-to-point connection, but we also can find out about what's our most adjacent neighbor. In this case, it's router 20.20.20.20. Again, that's why these OSPF IDs are so important, because it can help you determine, which router you're dealing with and which ones you're connected to. The show IP OSPF command is another very useful command for troubleshooting and gaining any information on your OSPF information, especially the part at the bottom that talks about the different areas. In this case, it would show you only areas you're directly connected to. So we're connected to the backbone and area 10 for the Seattle router, and it tells you how many interfaces. Is there authentication? You can check that kind of information here, and it's very, very important for your CCNA. So another one of my favorites is show IP OSPF border routers. I'm just going to quickly pass through this one. Tells you, is it an intra or inter-area route? And you can see here it's intra rather, these routes here, and because they're connected through area 0. And if another one that's very good here is show IP OSPF neighbor, and you can see the state of the route, of the OSPF configuration. And then show IP OSPF neighbor detail is another very important, because this can tell you about the designated router and backup designated router in the network. And that's pretty much covers everything on OSPF Basics. I just want to show you one more command. It's the show IP OSPF database. So this will show you all of the OSPF routers in our network. So that, again, how I said in the beginning, how OSPF creates a database for its routes. So this is very important to know how to understand this command and how to read it and use it for troubleshooting. And that pretty much covers our, all of the things I wanted to show you in this video. I hope it was helpful, and I hope it helps you with your CCNA studies. And thank you so much for watching.